All right, this is LeetCode number 14, longest common prefix. We're going to use a try on this. You just don't see it a lot, so I think this is a good data structure to use. It's really good for this problem. It's not going to be the fastest. The fastest is going to be twiddling with a bunch of pointers and just running through everything, and you can see a lot of those out there. That's probably the main solution for this. I think the try needs to be done on this. So, and it's not that much slower. C sharp. We're going to use the try. The point is we need all these words. What's the common prefix on these? Over here it's FL because they all start with FL. That's a one of the points you need to remember when doing this is it's got to be across every word because you're going to run into a problem later where it passes in an empty string, and that'll mess up your solution if you're not looking for stuff like that. So you could read it over here. It's all English letters. If it is blah 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 blah. Okay, you can read that. Here we go. Oh, I'm not going to type this out because this is way too long. It'd probably take me 40 minutes to type this stuff out. So I'm going to run through this with you here. So we have a class called try. We're going to create our root. This is just our constructor here where we're just instantiating a new node for root. Remember, root is the anchor. Okay, that's the anchor of the whole data structure. That's why when we start manipulating and running through this try, you don't want to use root because you'll lose that index and you won't know where to start later. You'll lose it. That's why we always make a temp variable like right here, node right there. Okay, here we go. Okay, so let's just go down here where it's gonna start at. Where's it at? This is our try node. It's got an end of word, a boolean, and then it's got the children there. Now, when we look for common prefix, we're only looking for one letter. If it's more than that, then it's no longer a common prefix. It can't be. It's always got to be one node into one node into one node. And then if it starts spreading out, that means there's more words and you're going to have different, they're all going to share that single line of connected nodes as the common prefix. So that's why we always look for one. Okay, so this is the function that LeetCode's going to call. It's going to pass us a string array of words. First thing we check is if it's empty, then we return empty. If there's only one word, we just return that word. So we create a try right here. There we go. That's from our class. And then we're going to run through the words, and this is important here. If one of those words is empty, automatically the whole solution is a blank string. So just return the blank, get it out of the way. Otherwise, we're going to add the word to the try. So we're going to call add. So let's go back up here. Here we go right here. We're passing in the word. We're going to create a try node. This is our temporary root node. Then we need to iterate the characters in there. Remember, we're running through every word and every character in the words because we've got to add them to this try. So that means we got an N for the words and then an M for each letter. So N times M. If you just think of characters, it's an ON solution. So what do we got? We got to grab the letter. If it's not in the dictionary, we're going to add it. That's what we're doing here. Update the pointer to the new try node right here, because this has been put in the dictionary under the key of our character that we grabbed right here. So that's what we do. Now we're pointing temp to that new node that we just created. And then if it's an end of word, we're going to go ahead and mark it as the end of word, that Boolean. And that's it. We'll go through every word like that. So then, what do we got here? It did that. Okay. Then we're going to return. It's going to come back. And then it's going to return try.getLongestPrefix. This is where the actual work is done. We prepared everything. We prepared our data structure. Now we're going to use it. And we're going to use it to find the longest prefix. So the first thing, this is important, the root, okay? When we start at the root, if there's more than one letter in the children dictionary, it's all over, return empty string. We can only have one letter across every word that's going to be a prefix. Remember, it's got to be common to every word. So if you had something like flower, flow, and cow, you got two F's two words start with F, one word starts with C. But if cow was, say, in the middle of the other two words, you can't just take the smallest word and then compare it with the biggest word to get the prefix, because you might have words in between those that don't even start with the same letter, and then it's all automatically invalidated. So think about that. Okay, so we knew up our string builders. We're going to have one, the current. That's just our working storage. That's where we keep our, kind of like a count, except we're adding the letters in that. And then we're always going to compare it with the final result, which is going to be returned. Okay, we're going to new up a queue of strings. Now, you could probably optimize this even more by not, maybe you can not use the queue. Just think about different things, play with it, see what you can come up with. But don't make it so hardcore that you can't read it, because out in the real world, you're gonna get dinged on stuff if you go into a code review and all your names are like X and Y and crap like that. You're gonna get dinged on it and you're gonna have to redo it. That's what they're gonna tell. I would, as a senior developer, yeah, you're gonna go back and redo that. We need to be able to read it. Just remember that. Okay, so here we go. We got our node. Remember, we need our temp for the root. I should have been consistent on that. You could have dinged me on that too, because I used temp up here or down there, and now I'm using node. There's a case for that too, where you want to be consistent. So yeah, ding on me. Got to redo it. Okay, put the first common prefix in the queue. Remember, we're on root. It's got to be only one. Might be able to figure out a different way of doing this, but anyway, process the queue. Okay, if you know DFS, if you've done the island problems, something like that, if you're using a BFS, you're familiar with queue. Okay, you're just gonna run through this till it's empty. So we're gonna pop it out in C#. It's called DQ, and then we're gonna add the current letter to the add letter current longest. Current.append letter. So we're adding this to the our working string builder. And then we're going to check to see if it's bigger than the longest so far. And if it is, then we're just going to append it to the longest. So set node pointer to new letter. We saw that last time in our add function, our method. So yeah, set it to the new one. Now we're pointing to the letter we just added. Okay, this is a big deal. Add child to queue. We're looking for exactly one child. We don't add this letter if it is an end of word letter, because it means we're about to go past a shorter word that was added earlier. This is really important. The longest common prefix can't be longer than the end of any word. This comes up because one of the cases, and I got dinged on this one. One of the one of the test cases is the words are A, B, and then A. So you add A, B into the try, A and B, and then you go back to add A. It's already in there, so it totally just screws everything up. You end up coming back with AB as the common prefix. So we need to know that it's not an end of word. Otherwise, we don't want to process and go any further with it. And that's it. Return the longest as a string. Let's go ahead and run this. See what we get right now. I've noticed with LeetCode, sometimes you'll get differences in the times, like 1 or 2 milliseconds or so. But anyway, let's do it. I got 4 milliseconds. Earlier I got 3 milliseconds, but it's still good. So we could run it. These 30%, beats 83 in memory. Like I said, not the fastest, but I think it's good to know this. This is really good stuff. Let's see if we can get it down to 3 milliseconds. Ah, we went up. That's what I was talking about. You never know. Try it again. Come on, LeetCode. Give me a good run. Looking for 3. Oh, we got it. There we go. All right, 3 milliseconds. That's it for this one, guys. Check out tries. I'm going to go ahead and put this on my GitHub if you want to do that. Yeah, otherwise, yeah. Yeah, you probably can't copy this. Okay. All right, I'll see you on the next one. Like, share, subscribe, create a bumper sticker. I will see you later.